Hello, I am Ahmad, and in this video, I'm going to talk about Taylor series and focus on Maclaurin series in general. So, this is very helpful in engineering as far as in many cases we need to approximate the function with the relevant series. So, Taylor introduced this expansion series in the 18th century, and the same century Maclaurin used the hypothesis of Taylor to expand the function around point zero. So let's go through this and learn something new. So if we have a function like y equals to fx and we want to expand it around a point like a, we want to have a sum of infinity series around a that the function is the same as its series. So in the Taylor equation, fx can be written as summation of f at point a, the nth derivatives, divided by n factorial times x minus a power by n. This is the general form of the Taylor equation. For example, if you want to write if fx is x2 plus x plus 1 and you are interested to write fx, for example, at point 1, a equals to 1, then you need to make several derivatives. As far as it's a polynomial, so after the second or third derivatives, the equation, the derivatives will be 0. So fx is x2 power x plus 1. F prime x is 2x plus 1. Second derivative will be 2 and the third derivative will be 0. F at 1 will be 3. F prime at 1 will be 3. Second derivative at 1 will be 2. And the next one at point 1 will be 0. So according to the Taylor equation, now I can write fx according to Taylor equation. It will be f0 at point a, which is 1, divided by 0 factorial times x minus 1 over by 0, plus first derivative 1 factorial x minus 1 plus second derivative 2 factorial x minus 1. The third one 3 factorial x minus 1 over by 3. So the rest will be 0 in this case. So fx can be written as 3 divided by 1. X minus 1 power by 0 will be 1, plus f prime will be 3 divided by 1 times x minus 1 plus 2 divided by 2 factorial, which is 2 times x minus 1 power by 2, and the third one will be 0. So it will be 3 plus 3x minus 3 plus x2 minus 2x plus 1, and it will be x2 plus x plus 1. So this is a very simple example just to understand how it works. This is not the use of Taylor equation indeed. If the point of interest a is 0, then it is called Maclaurin series. So it means that we want to find out the function of x close to point 0 or expand it close to point 0, and it is going to be used for approximation. If a approaches to 0, then Maclaurin series is a extension to Taylor series or attachment to that. So f x will be f at 0 divided by 0 factorial x minus 0 power by 0 plus f prime 0 1 factorial x minus 0 power by 1. Second derivative divided by 2 factorial x minus 0 power by 2 plus the third one, and so on. I can simplify this. It will be f0 plus f prime 0 x plus second derivative 2 factorial x2, the third derivatives 3 factorial x3, and this is the Maclaurin equation. Now we can go through one famous example. For example, if fx is sinus x, so f prime x will be cosinus x, second derivative will be minus sinus x, third one will be minus cosinus x, and so on. Now we need to calculate function and all derivatives in the point of interest, which in Maclaurin series it's always 0. So f at point 0 will be 0, f prime at point 0 will be 1, second derivative will be 0, third one will be minus 1, and so on. Every other one, as far as sinus will appear, will be 0, and every other one will be 1 minus 1 because of cosinus. Now we can write down that sinus x can be written as f0, which is 0, plus 1 times x plus 0 x power by 2 plus minus 1 divided by 6 x3, and so on. So sinus x can be written as x minus 1 over 6 x3, and the next one will be the order of 5, which is 5 factorial x5 minus 1 over 7 factorial x7, and so on. Now, if you are going to make the limit or simplify an equation, you can see that the higher order of x is closer to 0. As a result, you can ignore them. So this is very useful tool for approximation. Let's go to one more example. Cosinus x is also one of them. So fx is cosinus x, f prime x is minus sinus x, second derivative minus cosinus x, third one sinus x, and so on. So f at 0 will be 1, first derivative 0, second one minus 1, and so on. Again, as far as you see sinus, every other one, the answer will be 0. If I substitute these in the format of Maclaurin series, so I can rewrite cosinus x will be 1 plus 0 x power by 1 divided by 1 factorial minus 1 x power by 2 2 factorial plus 0 x3 3 factorial, and so on. So it will be, next one will be plus 1 over 4 factorial x power by 4, and then I can simplify it. Cosinus x will be 1 minus x2 over 2 plus 1 over 4 factorial x4, and so on. Now, the other good example is about the square root equations. For example, if fx is square root of 1 plus x. So fx is 1 plus x s square root, and f prime x, it is easier if we write it down with this one. So f prime x will be 1 over 2, 1 plus x powered by minus 1 over 2. F second x will be minus 1 over 4, 1 plus x powered by minus 3 over 2. And then the third one will be 3 over 8, 1 plus x minus 5 over 2. So f at 0 will be 1. F prime at 0 will be 1 over 2. The second derivative will be minus 1 over 4. And the third one will be 3 over 8. So I can write down the Maclaurin series for this one. So square root of 1 plus x will be f0, which is 1, plus 1 over 2x minus 1 over 4 divided by 2 factorial x2 plus 3 over 8, 3 factorial x powered by 3. So it will be 1 plus 1 over 2x minus 1 over 8 x2 plus, so 3 and 3, 2, 8, 16, 1 over 16 x3, and so on. Similarly, if you have 1 plus x powered by 2, then you can write it down as 1 plus 1 over 2 x2 minus 1 over 8 x2 powered by 2, 1 over 16 x2 powered by 3, and so on. Usually when x approaches to 0, then the higher orders of x might be very close to 0, for example x4 and x6, then you can just neglect them. Also, it is very interesting that you can just find out what kind of function you have instead of x in this function of square root of 1 plus x. I can bring this to the next page. Now, if you have square root of 1 minus x, you just simply substitute minus x instead of x. I can write down this function as 1 plus minus x. So it will be 1 plus 1 over 2 minus x minus 1 over 8 minus x powered by 2 plus 1 over 16 minus x powered by 3, and so on. Or if you have 1 minus x powered by 2, you can just simply write it down that it is 1 plus minus x powered by 2. So it will be 1 plus 1 over 2 minus x2 minus 1 over 8 minus x2 powered by 2 plus 1 over 16 minus x2 powered by 3, and so on. So I can simplify this. 1 minus x2 will be 1 minus 1 over 2x2 minus 1 over 8x4 minus 1 over 16x6, and that's simple. Now, as far as we are familiar with this Maclaurin series, so here I can write down that sinus x when x approaches to 0 is almost x. If you want to more or higher orders, you can add that part as well. So cosinus x when x approaches to 0, it will be 1 minus x2 over 2. So consider that sinus x approximation to x is 2 sentences or 2 first terms of the Maclaurin series. The first one was already 0. So, and 1 plus x when x approaches to 0 will be 1 plus 1 over 2x. So these are very typical approximations that might be used for the stability, for example, or other engineering matters. That's the end of this video. We didn't go through very complicated mathematics. We just wanted to have some brief explanation about Maclaurin series, that how it would work. So that's very, very easy for this part. Thank you and see you in the next video. Bye.